Okay, and we are back with the other thing we have to do for coordinate geometry, because I think it might be coming, which is sketching quadratics and in general the graph of a quadratic. Now, as you can see here, the graph of a quadratic isn't in the form of a straight line. The quadratic curve, which is called a parabola, because you see it's like that. It's not really a circle, it's not really a U or anything like that, it's called a parabola. It's a function of the form f of x is equal to ax squared plus bx plus c, or y is equal to ax squared plus bx plus c. In the case of the one here that is on the screen right now, a is equal to 1, which means that y is equal to 1x squared, b is equal to 2, and c is equal to minus 3. So this would really be y is equal to 1x squared plus 2x minus 3. That's like what it looks like on a graph. Now, remember, for a quadratic function, a is not equal to 0. In other words, like if a was 0, it would just be a straight line because it'll be no x squared. 0 by x squared is 0. So in this case, we're looking at 1. Now, if you didn't have this lovely software like I have, you still have to plot a quadratic for test, most likely. So how are you going to do that, knowing absolutely nothing? Let me X this off. The first thing you need, there are a few things you need. You need the Y-intercept, you need the roots or the X-intercepts. Those are the two places it hits the X-axis. And you need the maximum or minimum point. Now, to find these, you could use equations. Now let me see if I could get a nice quadratic really quick. Any quadratics randomly here, sitting around the place? Oh, by the way, the whole reason it looks like this is because this isn't a linear equation, what they would call a linear equation. Like, if A is 1, let's just say B is 0, B is 0, C is 0. This is essentially the graph of y is equal to x squared, because 0 by x is 0, plus 0 is 0. So, see 0, 0, 0 squared is 0, 1 squared is 1, but 2 squared isn't 2, it's 4. And you see, it means it's not really a line, it's more of a curve. So yeah, but I don't think I have, here's a nice one, probably a nice one. Yeah, they have. So let's pretend we had none of this stuff. We had none of these beautiful graphing calculators. And let me just get rid of this example. And we just were told we have to plot a graph of y is equal to 2x squared. I'm sort of cheating by actually putting it here. Plus 7x minus 5? Minus 7x minus 5, sorry. I literally just opened the book. I should have probably thought of getting that before I did this. Yes, I should have. So, this is sort of what it would look like. And you have to plot it without knowing anything. So the first thing, as I said, like the same thing with the other one, the equations are all on the right. So, the first thing that you have to find, and I'll use this in an example so you can tell, changes back to like what, 1, changes back to minus 3. It doesn't really matter. I'll show you. The first thing you have to find is the y-intercept, and that is where this line meets the y-axis. Now, it's equal to sort of your constant, but you could also look at it as where x is equal to 0, because you see, wherever the y and x axes meet, x is always equal to 0 here, right? Here's 0, but here is not 0, right? So, to calculate your y-intercept, you would set x to 0, as I have in the thing there. And let me just get a paper to prove it. So, with y is equal to 2x squared minus 7x plus 5, setting x to 0, or you could write when x is equal to 0, y is equal to 2 into 0 squared minus 7 into 0 minus 5. So y is equal to 0 minus 0 minus 5. Y is equal to minus 5. So that's the first thing. And as I said, where your y-intercept is, your x will always equal to 0. So if we click here, it should say, yep, 0 minus 5. Those are the coordinates of your y-intercept. Now, next thing you need to find is your x-intercept. Now your x-intercept is where it hits the x-axis. And as you can see, where your line hits the x-axis, y is equal to 0. So now you have to say 2x, you do the same thing you do for finding the y-intercept. You set, except this time, you set y to 0. So 2x squared minus 7x minus 5. Because at equals 0. Because that's where this line meets the x-axis. So from that you'd solve the quadratic equation, like factorize it. And you would get 2x squared, I think, minus 2x or something. 1 second. Let me just... Oh, I should have done this before. I don't know why I didn't. So yeah, 2 by 5 is 10. Minus 10. Yeah, minus 10. Yeah. That would be... whatever that is. Yeah. The point is... I won't actually bother doing it. I could do it, but like, you'd get x plus something into x minus something. Therefore, x plus something is equal to 0, or x minus something is equal to 0. Now, I mean, x is equal to minus something, or x is equal to something. I hope you work this out yourself. And let's see what they are. So... I said let's see what they are. I'm terrible. I should know how to do this. But in this case, aha, it's not a real number. I'm not crazy. Yeah. X would be equal to that, negative 0.608. But x would be equal to 4.108. And you could do that using the quadratic formula. Or they'll probably give you something nice that you could factorize by hand. And the last thing you need to know with this is your maximum or minimum point. And with that, you also have to know your axis of symmetry. Now, your axis of symmetry is like this sort of line going through the middle here, where your curve turns. So it's sort of like the mirror line, if that makes sense. And to find that, you use the equation minus v over 2a. So in this case, b is 7, so it's negative 7 over 2 by 2 is 4. So that would be 7 over 4, which would be just 7 over 4. I won't bother doing it any simpler than that. So it'll be x is equal to 7 over 4. Because remember, a vertical line would be on, like, just x is equal to something, right? X is equal to a constant. So that is your axis of symmetry. Now you could also find your maximum point. I mean, they might ask you for the axis of symmetry anyway. But you could also find your maximum point by reading it from the completed square form. But we're not going to do that, because for me at least, it's simpler to do the same thing we were talking about in the last thing with lines and solve the two simultaneously. So when an equation solves simultaneously, it means where two lines meet. So x is equal to 7 over 4 and y is equal to 2x squared minus 7x plus 5. If you solve these simultaneously, or you just put like 7 over 4 wherever x is in this case, you would find this point here. So let's do it. You just substitute it in there. So that's like the substitution method. So y is equal to 2 into 7 over 4 squared minus 7 into 7 over 4 minus 5. So y is equal to 7 over 4 squared is 49 over 16. As I said, it probably won't come like this. It'll be some nicer numbers. Minus 49 over 4. Minus 5. 5 just stays as this. I'm trying to read on something I scribbled on. I'm terrible. So y is equal to 49 over 8 minus, well, 49 on 4 is the same as 98 over 8 minus 40 over 8. I should really just get a calculator into this. But yeah, 48 minus 98, 15 minus 4. Okay. The whole point is you'll get a number. And the number is that. Remember, this is in thing. So when you do that, actually, I did a terrible explanation of this. Wow. Yeah. When you solve them simultaneously, you get y is equal to a number, right? Then you put that back into the, well, that'll be your x coordinate is this, 7 over 4, which is 1.75. And your y coordinate is whatever you got. In this case, it's negative 11 and 1/8, or that would be 89 over 8. Yeah, it'd be something like that. And that is essentially how you'd sketch a quadratic. I think to make it look nicer, you'd also find some random other points here, like somewhere, just so that you know how to draw it. But this is all the basic stuff you need to know how to sketch a quadratic with. I hope I didn't do this one too confusing, because this is probably the more difficult one. So again, good luck in your exams and all the best. See ya. Let me just